Right, so what are the two variables that change with the different types of electromagnetic radiation? All right, we wrote down, we got this yesterday. Here, let me make this bigger so you guys can really see. We wrote down wavelength and energy. Those are the two things that we're going to change with each electromagnetic radiation, right? So if I go up here, I change the wavelength. If I, just like we did in our bell ringer, if I take this wavelength and I stretch it out or make it longer, it's going to change the energy, okay? Or type of energy. The number 2 question, highlight the appropriate words to describe the waves at the left end of the wave spectrum. So I'm going to go over this. I'm then going to pause the video and we'll see what you guys come up with. So over on this end, is the wavelength long or is it short? So you're highlighting one of those. Is it a long wavelength or is it a short wavelength? The frequency, is it a high frequency or a low frequency? So frequency, remember, is how many waves go by in a minute or in a second. It's how quickly these waves are moving by. And then energy, is it high or low energy? Just as a hint, whatever frequency, if it's high or low, the energy is the same. Okay? So, play. All right, so because these waves are all kinds of like stretched out, the wavelength is considered long. The frequency and the energy are considered low. It's low energy. There's not a lot of energy being put into this. Okay? We go down to the next one. Highlight the appropriate words to describe the waves on the right end of this spectrum, of the electromagnetic spectrum. So, this wavelength, is it long or short over here? Is the frequency and energy high or is it low? On this end here, what we're seeing is the wavelength is short. So from crest to crest, it's really a short distance. The frequency is high and the energy is super high. All right, so this next bit, we're going to fill in the boxes underneath the wave spectrum to indicate the relative position of each type of electromagnetic radiation from the given word bank. So we're going to double click the image to open the drawing and double click each box to start typing. So double click, and there it is. All right, never mind. So there it is. So really we need to start on one end and figure out, okay, so let's start on the long end. You gotta think about what is the longest wavelength energy type from these options. So once you go through, this is the answer that you guys got, or should have gotten, that the longest wavelength is radio, the shortest is gamma, and everything in between in that order. All right, so you save and close. Good job. And then looking at this, we're going to answer number 5. So we're looking at the wavelengths there. We're looking at the energies underneath. So highlight the appropriate words. Which has a longer wavelength? So you're comparing to visible or infrared. Which one has a longer wavelength? Which contains more energy? Visible or infrared? Which has a higher frequency? Visible or infrared? All right, so just to recap, infrared has a longer wavelength. It's closer to this end than visible, where these are long waves. Visible has a higher energy because it's more jumping around like that, squiggle, squiggle, squiggle. And then the frequency, remember, is pretty much the same as the energy, where it's going to have more or a higher frequency because of that energy. All right. Now it says, number 6, look carefully at the electromagnetic spectrum shown below, paying attention to the wavelengths and frequencies indicated. Fill in the blanks with the correct colors from the visible spectrum. So think the rainbow. I don't know if you guys remember Roy G. Biv, so Roy G. Biv, red, orange, yellow. That spells Roy. G, green, Biv, blue, indigo, violet. Okay, so look carefully at the electromagnetic spectrum shown. Blah, blah, I already read that. So we're shading in the rectangles and figuring out which color would have the longest wavelength and which color would have the shortest wavelength. And then you just think Roy G. Biv or whatever. Okay, so which color has the longest? Should we start with longest? Let's start with longest. Which color has the longest wavelength? All right, so once you've figured out that red is the longest wavelength of all the colors, you can then just think Roy G. Biv and fill this out. So red, Roy, R-O-Y, red, orange, yellow. So this is orange. Let's fill it orange, red, orange, yellow. Roy G. Biv. Red, orange, yellow, green. Blue. Boom, boom, boom. And indigo is like a mixture of blue and purple. So I'm going to see if I have anything that's kind of in the middle. Maybe this. Indigo, kind of. That one you're going to have to kind of guess. And then violet is just the fancy word for purple. Okay, so Roy G. Biv, purple is the fastest wavelength. Red is the lowest wavelength. And it's kind of crazy. So if you were a scuba diver and you like went into the ocean, because red is the lowest and like the less energy, that color of light can't go very far into the water. It like can only go so far and then it kind of like disappears. So, in the Disney movie Little Mermaid with Ariel having red hair, she's hanging out at the bottom of the ocean. That's a lie. Red wouldn't touch the bottom of the ocean. Okay, that color would be filtered out first. In fact, if you're a scuba diver and you reach that point below where red can reach, that color of light or that wavelength, and you cut yourself, your blood would look gray. It wouldn't look red at all under the water below where red could go. So let me see if I can find that actually. So color filtered out through water depth. If we can get an image. Yeah, okay, so you look here and you go below 5 meters in water and that color disappears. It doesn't reach any further because it has low energy. Whereas like dark blue, purple, this would probably be like an indigo, right? That can go 35 meters down. That wavelength of light has more energy. It can go further down into the ocean. Whereas these colors, they filter out faster. The lower the energy, it can't go far into the water. Okay? Just a fun fact. Anyway, save and close. All right. What is the general relationship between wavelength and energy? So I'm going to start, remember, relationship, there's a certain way you start the sentence. So we're going to talk about wavelength. So if the wavelength is long, then the energy will be, you guys need to finish the sentence. So the energy will be low, okay? All electromagnetic waves travel at this speed in a vacuum. Does anyone remember? But it is, all waves move at the speed of light. So all electromagnetic energies move at the speed of light. Boom. Let me read this one. So, number 9, do electromagnetic waves transmit energy or mass? That is the question. The answer, you guys crushed it, is energy. All right, go ahead and push submit after you have this down. Ya done.